for admission for you. So for the number question 1, this is written as question 4, so I'm gonna number this as question 4, but this is the first question on the question zone. So the regular motions of the Earth about the Sun causes the daily change in the high temperature at any location on Earth. The chart and graph show the average daily high temperature in degrees Celsius for each month in Yellowknife and WT and compiled for several years. Determine the trigonometric equation that models this transformation. Let y be the temperature in degrees Celsius and yx be the numerical values of this month. So this is the table given in the question, and this is the graph given. And yeah, so I've already redrawn the table for this information. So I let x equal to 1. So I let the x equal to 1 for the January until the December. So it's going to be 12. 12 resemble December. So this is the value, the Celsius value for each month. So in order to find the trigonometric equations, we need to know the maximum value and minimum value first. So since it's the equation this is the equation that we need to find or we need to fill on. Sorry. So first thing first, this is the A, which means amplitude. So in order to find the amplitude for this equation, we need to know the maximum values or minimum value. So maximum value in the whole year is the 21, which is on July, and the minimum value is in January. So maximum. So this is the equation for finding an amplitude: maximum minus minimum divided by 2. So it's gonna be the answer is gonna be the answer for A is gonna be 22.5. So another one, we need to find K. So in order to find K, there is the equation period equal to 2 pi divided by K. So this is the whole year, so it's going to be 12 months. So also the periods are going to be 12 months as well. So this is the 12K. So K multiply K on both sides, so this is going to be 12K. So 12K equal to 2 pi means K equal to pi over pi divided by 6. This is the value for K here. So and then we need to find D. So for the values of D mean the translation, horizontal translation. So we need to look at the minimum to maximum value, because we need to find the translation from right here to here. So translation to the right 7 units from minimum to maximum. So while we look at the graph, it took 7 months. This is July, this is January. So it took 7 months from the minimum points to the maximum. So the values of D is gonna be 7, like positive 7. And also we've done A, K, and D. So this the last thing we're gonna find is the C. So C, there's an equation: maximum plus minimum divided by 2. This is gonna be the values for C, which is the C means it can be concluded as a midline or the vertical translation. So this is the final equation. Y equal to 22.5 cosine pi over 2 times x minus 7 minus 1.5. So the reason why I choose cosine function, because I've already checked the answer. So for the cosine function, it gives a little different result from this. So I think cosine function is the more suitable than the sine function. So this is the answer for the first question. So for the number 2, a Ferris wheel has a diameter of 10 meters and takes 24 seconds to make 1 revolution. The lowest point on the wheel is 1 meter above the ground. Number A. Sketch a graph to show how a rider's height above the ground varies with times as the Ferris wheel makes a rotation. Assume the person starts the ride at the lowest point on the wheel. So the key points on the question is the lowest point. The lowest on the wheel is 1 meter above the ground. So we need to start considering the 1 meter above the ground. So not as a zero. And this is the wheel has a diameter of 10 meter. So before I sketch the graph, I try to understand with this small representation. So this is going to be the wheel, and this is going to be the start point, which is 1 meter above the ground, and this is the lowest point here, lowest point on the wheel here. So the diameter, so this is the diameter, and this is also a diameter. So it's going to be the 10 meter total, like from here to here is 10 meter. So before I sketch the graph, I drew the table. So at times zero, the question said the lowest point on wheel is above 1 meter, so which means that times equal to 0, and the wheel is gonna be at the 1 meter. So we don't start at 0 meters, we start at 1 meter. So since it is a 24-second, I try to simplify into like 1, 2, 3, 4, 5 sections. So 0 second, 6 second, 12 second, 18 second, 24 seconds. So for 6 second, which is this take a total of 24 seconds, right? So this is going to be 6, 12, 18, and this is going to be 24, which is the start point. So this is going to be the same as a 0 second. So at 0 second, it's a 1 meter. At 6 second, it's going to be 6 meter because the whole diameter of the wheel is 10 meter. So which means the radius is 5. So we look at the 6 second. So the position of 6 seconds stands in the 5 meter. So this is going to be 5. So 5 plus 1 equal to 6. So that's why at 6 second, the wheel is going to be, so the start point is going to be at the 6 meter above the ground. So at 12 seconds, this is the same as before. The whole diameter is at 12 seconds, the whole diameter plus 1 is going to be 11. At 18 seconds, it's going to be 6 again, and 24 seconds is going to return the original point, so it's going to be 1 meter above the ground. So this is my graph, and I've already drawn that. So 0, 6, 12, 18, and 24. It's a little bit ugly, but yeah, I think it might be the good representation for the graph. So for number B, write a trigonometric equation that describes the graph. So as the same as before we did on the first questions, we're going to use the cosine function as well. So we're going to find A, we're going to find C, we're going to find the values of K, we're going to find the values of D. So I've already carried out, so we're going to start with A, of course, maximum minus minimum divided by 2. So in this situation, maximum is 11 meter above the ground, and minimum is 1 meter above the ground. So 11 minus 1 divided by 2 is 5. So for the values of K, so period is the 24 second. So 24 second took, so it's what wheels took to take one rotation. So 2 pi over K, it's equal to 24 second. So it's gonna be, we're gonna multiply K to the both sides, and it's gonna be K equal to 2 pi over 12. And this is C. This is the equation maximum plus minimum divided by 2. 11 plus 1 divided by 2 is 6. And D is horizontal translation. So the final trigonometric equation is y equal to, this is the original format, y equal to a cosine k x minus d plus c. So since it is a time in the function, so h of t equal to 5 cosine pi over 12, t minus 12 plus 6. For number C, check the accuracy of your equation by using t equal to 12 seconds. Explain why this provides a check of the accuracy of the equation. What are two more values that would provide a good check? So I've calculated with t equal to 12. So this is going to be 5 cosine pi over 12 in times 12 minus 12 plus 6. So the value is 12. So if we check, this is the t equal to 12 second, and the height is going to be 11 meters. So I think my equation is correct. So I've written the explanation. This provides a check of the accuracy of the equation because in the graph, the maximum height is 11 meters, and also when we substitute t equal to 12, the answer was also 11. Hence, it can be concluded that equation is correct as it reached the maximum value. So, the question asks two more values that would provide a good check. So it's gonna be for accuracy, of course. So one, t equal to t. So that means that h of t equal to 5 cosine pi over 12, 6 minus 12 plus c. So we're gonna substitute t equal to 6. So this is the same as 6. Like I've written before. When t equal to 6 second, the height's gonna be 6. So when t equal to 0, the height's gonna be 1. So I think my equation is correct. So for the number 3, the height of the tide in the Bay of Fundy relative to a pier varies from a low of 4.5 meter at 2 hours and 8 minutes to a height of 17.3 meter at 8 hours 21 minutes, measured at 24 o'clock. So this is going to be at 12 in the morning, and this is also as 12 in the morning. So for the number question A, assume that the height h of the tide can be modeled as the cosine functions of the time of the day, t, and then determine the equation in the form. So this is the function that we're going to find for. The process is the same as we did before. So we're going to find the maximum height and minimum height first. So maximum height is 17.3 meter, and the minimum height is 4.5 meter. So to find the amplitude, maximum minus minimum divided by 2, so this is going to be the values of A. So time taken. So to consider the period, in order to find the values of K, we need to know the period. So since in the question, period is not given, as we did on the last two questions, so we need to find the period itself. Time taken is equal to period. So it's going to be 8 hours. So we're going to turn this hours into just not as the hours a minute. We're going to turn this to the whole hour. So it's going to be 21 over 60 minus 8 over 60 into 2. So the reason why I multiply with 2, because we need we need a full circles of period. For example, let's say this is a sine, and this is gonna be the full period of the sine function. So we need to multiply with 2. So this is gonna be the 373 over 30 hours. So for period, we've already got this. So period equal 2 pi over k. So for k, we got 60 pi over 273. So D is a horizontal translation, so it's gonna be this. 821 over 60, 8.35. So for the C as well, this is maximum plus minimum divided by 2. It's gonna be 10.9. So for the trigonometric equation, we're going to substitute all the values that we get from before. So this is going to be a equal to 6.4 cosine 60 points over 373 times t minus 8.35 plus 10.9. This is going to be our final trigonometric equations. So B, where h of t is the height of the tide at the pair in meters and t is the time of the day in hours. Determine, so this is the question for number B. Well, I suppose that is not a full question, so we're gonna go straight to the number C. Determine the, I think that is the question error. So we're gonna go straight to the number C. Determine the height of the tide relative to the pier at 11:30. Give your answer to the nearest 0.1 meter. So for the number C, we need to find the total hours for total hours for 11 and 30, which means, so this is giving 11 and 30, this is 11 and 30 minutes mean 11.5 hours. So at 11.5 hours, so we need to know what is height of the tide gonna be at 11.5 hours. So we substituted to the equation that we got from the number A. Yeah. So 6.4 cosine 60 pi over 373 times 11.5 minus 8.35 plus 10.9. So this is the height of the tide when it is 11.5 when at 11.5 hours. So this is the, I think this is the end of the question C. So for the number D, a boat needs a depth of at least 12 meters to dock at a pier. Uses the graphical approach to determine when the boat is able to dock and when it must leave. So I have already drawn the table for the graph. So this is my function that we got from earlier of the question. So this is a graph. So I used it with the decimal point, not as a full number, like real number, because I think it's more suitable to draw a graph for this question because we've already, so for the questions that the point is going to be really hard to determine where the points is going to be at each different hour. So I've already drawn it online with this function. So the perfect point for this equation is going to be this 0, 2.13, 7.3, 8.35. So I've already drawn the graph for this. Yeah. So since the question is given as at least 12 meters to dock at the pier, we need to separate 12 meters from this because this is the minimum point to dock. So I've already given the explanation. The boat is able to dock between 5:30 and 11, and also between 18:30 and 23:30, because it passed through these 4 points, 1, 2, 3, 4, and the time is approximately 5:30, and the next time is approximately 11. So the boat is able to leave. Those able to dock between these time when the tide is high. So then also this time as well, 18:30 and 20:30, 23:30. So these two times, these two interval, so towards it will to dock. And then the boat must leave between 0.0 to 5:30 when the tide is low at the minimum, and also 11:30 and 18:30. So that is the end of the question and also end of my presentation. Thank you.